So now I return back again to the data. So we saw that we are not good, and then in the accident in Germany, and when we try to focus again on the fault of driver, what's happened? We see that there is an influence of alcohol, that you can see the number, 12,000 accidents a year or 13,000 accidents a year. This is a very, very high number. So this is in Germany, where you have a very, very restricted law enforcement. But still, 12,000 is a lot. And here you simply lose your driving license. So the law enforcement is very strict about this. But anyhow, 12,000 is very, very high. Improper road use, inappropriate speed, insufficient distance, overtaking mistakes, failure to yield the right of way. This is a very, very high number when you drive in the city and you don't pay attention who has the priority and you violate that, it results in an accident. Turning off mistake in starting off or entering the road from premises or etc. Improper behavior towards pedestrian. These are very, very high numbers. So you can see that in most of accidents, so we are talking about 360,000 in 2017, or I don't include 2020 because of the COVID effect, but in 2019, 355,000, simply driver-related cause of accident. This is very, very high. So, and as I said, this is in Germany. When we talk about the other countries, definitely there are in most of cases the number gets higher and higher. So now comes the biggest question that we need to ask ourselves: what is the solution? How we can avoid all of this? Because we saw that lots of accidents happen, lots of people they die, lots of children they die, and this is very sad. And how we can avoid it? So what will be the solution? So one of the solution that we are definitely sure that it works, because we see its effect already on the road, is simply to reduce the driver error. And how we reduce the driver error is that we assist the driver. It means that you build the function that what we call driving assistance system, DAS, or advanced driving assistance system, ADAS or ADAS. These are the system that it already exists in the current car. If you buy a car, mostly after 2017 or 18, or also before that, there are the first generation of the ACC, also much before that, they have this kind of driver assistance system. What it means that now in all the modern car that you buy, it must not be a fancy car. I'm talking about simply a modern car. You have some camera involved inside the mirror that track your eyes. And if you don't pay enough attention, or it detects based on your eyes movement that you are tired, it gives you a warning that, hey, you don't pay enough attention to the road, or you are tired, stop, take a rest, and then drive. There are some assistance systems that take a look to see what is, or how much is your vision. If the road is if the road is foggy, then it turns on some extra light for you, or it will adjust the lighting system for you. There are a driver monitoring system, as I mentioned. There is this blind spot monitor system, with the abbreviation BSM. We all know about blind spot. When you are driving, if someone in a special position next to you on your left or on your right, is that you don't see him because he's not inside your mirror. And unless you rotate and have a look above your shoulder, you will not see it. But there are some systems that the moment that you activate your indicator and say that I want to change my lane, the system beeps and said, hey, don't do it. There is someone there. You cannot change your lane. Some advanced system, you have some vibration on the steering wheel, or you cannot even steer because it brings you back on your lane. So it assists you. And this is very, very important when we take a look and see how many accidents simply each year happen because we don't have a good sight on a blind spot. And if we avoid this, then we don't have all of this accident. This is a huge number. As I said, we have the night vision assistant. You have adaptive cruise control, which is a very, very good system. It's already exists. The first generation are already maybe a decade or more old. They are the system that simply you can activate it. They keep a constant velocity, and also they keep the time headway to the vehicle in front of you. So it means that if there is someone in front of you, they adjust the velocity. If they need to brake, they brake. How much they brake? They reduce the velocity till that you keep a safe headway. So, and this headway is based on the time headway, usually is around 2 seconds, 1.5, 2 second time headway, which is very safe. This is the time headway that also when you drive your car, you learn at the driving school, try always to keep 2 second time headway. So then this is adaptive, it adjusts the velocity, and most of modern cars, they already have this, and this really helps because if something goes wrong, the guy in front of you suddenly does an emergency brake, you have 2 seconds. Of course, the system brakes, but if the braking of the system is not enough and you pay attention, you have enough time to react also. We have lane keeping system. We have the lane keeping system. What it does is that if you suddenly go out of your lane without any intention, this happens a lot. You see it in the daily life that you are driving and someone slowly try to change the lane, but it's in intention, just simply he doesn't pay enough attention. So there are the lane keeping system. Some of them, they warn you, the system beeps. Some of them, you have some movement on the steering wheel. The steering wheel brings you back on your lane. Then we have electronic stability control, ESC, which is obligatory, if I'm not mistaken, since 2018. And just to take a look and it detects if you have any loss of traction, and then it apply different braking to each wheel separately and individually. So most of modern cars, they have it. And we are so much used to it that if you try to drift your car, it never happens if your ESC system is on. But with the moment that you turn it off, you can do all the dangerous movement and the drifting. But with the ESC, your car stay always stable. And these are mandatory right now in Europe at least. So when you buy a car, they all have it. And what we see here is that we see that the statistics and the number suggest and says that using the technology will dramatically reduce the number of the road accident and, of course, the fatality and the death. So we must move towards using the technology. But when we talk about using technology, what it comes always to the mind of people is simply that we have the conventional car, a car that does nothing. Me as a driver, I must do everything. So this is more than 90% of the car that you see in the society. And the opposite, we see an autonomous car, a car that does everything, a car that you don't need even a driver. But it's not like this. Between that, you have 6 different levels of automation. So we call it level 0 to level 5. So we have 5 levels, but we need also to include level 0. So what it is, and then who defined that? This definition is included in SAE J3016 with the name of levels of driving automation, and SAE is an abbreviation for the Society of Automobile Engineers. So they define, there is also some American definition, which is very, very similar, only 1 level less. But at the end, we have this. And what it means that you have at level 0, no automation, a conventional car, but doesn't mean an old car. You can have a new car with lots of sensor. Now we talk about it, but it still can be level 0. Then we have level 1, which is driver assistant. We have level 2, which is partial automation. And there is a line here. It means that this is the 3 level that already exist on society right now. Anything above that doesn't exist yet. It means that it is in the stage of research and development, but you cannot go to market and buy a car, the latest Mercedes or the latest Ford or any other car that you buy, they only have level 0, level 1, or maximum level 2. And as you can see here, I put a picture of a Tesla. So when we talk about the autopilot of the Tesla, we are not talking about full automation. We are still far, far, far away from full automation. Most of people, they think that autopilot of Tesla, that you press a button and the car drives, this is an autonomous car. No, it is not an autonomous car. So then we have level 3, as I said, doesn't exist yet on the market, is conditional automation. Level 4, we have high automation, and level 5, we have full automation. As an example of the level 4, probably all of you saw the example of the Google Drive car. So you have a Google car that drives autonomous, and this is level 4 because you have a driver on board. What is a car that you know, okay, I am here right now. I would like to drive to my destination point B. So it drives from A to B autonomous. So these are these 6 levels of automation. And now we take a look to each of them. So Level 0, as I said, means no automation. But how we define these different levels? So first of all, we need to take a look to the execution of steering and acceleration, deceleration. It means that who will move the steering wheel and who will press your gas pedal or throttle and who will press the brake pedal. And you can see that in the level 0, this task must definitely be done by the human driver. Then we have the other very important category, which is monitoring of driving environment. Who take a look to the environment, the perception? Who does it? This is human driver. The fallback, if something goes wrong, the fallback performance of dynamic driving task in level 0 is human driver. System capability, driving modes, some driving modes. So the example, most of the car that you see in the society. So they are all level 0. I don't say all of them, but I say most of them. But this doesn't mean that the car must be old. Don't picture the car of your grandfather. No, this means that you can have a new car that have a lane departure warning. It warns you. It doesn't take any action. So if you go out of your lane, it simply beeps, or it seems you have some vibration on the steering wheel. You can have a forward collision warning. If you collide with someone in front of you, the system gives in the HMI and says brake. You can have blind spot detection. If you try to put your indicator and change lane and there is someone in the blind spot, the system beeps. So long story short is that you can have a modern car with all of these sensors that they warn you, but is still considered vehicle 0 because the person or who must execute the control of the car or who control the car is human. Who monitor the environment is human. And who is responsible for the fallback scenario is still human. So this is the definition of the level 0. Now you can picture and take a look to see, okay, the car that I own, which level it is. And you can find out, okay, that most of our cars, it belongs to the level 0. Then we have level 1. In level 1, what is happening is that the execution of a steering and acceleration, so it means that the control of the car is divided between human driver and the system. It means that there are some driving modes that is happening by the system. The system will accelerate for us if it's necessary, or the system will decelerate for us, or the system will apply some control on the steering wheel. It means that the system does something. Then we have the monitoring of the driving environment. Who is responsible to take a look to the environment and does the perception is definitely human driver. And the fallback, if something goes wrong, is human driver. And we have lots of cars in the society like this. If you have a car that has an ACC, has an adaptive cruise controller, take a look and adjust the speed to keep always a safe headway to the preceding vehicle, then we are talking about level 1 automation. Or if you have a car that has a parking assistant, lots of cars, they have parking assistant, most of them with a lateral control. It means that you are the one who gives the gas and the braking pedal, and the system automatically steers for you and brings you to the parking spot. So this is an example of level 1. Then we have the maybe most interesting level of automation, and this is level 2. The level 2, this is partial automation. So it means that the execution of a steering and acceleration and deceleration can be done completely by the system, like the Tesla autopilot. When you activate the autopilot, the system does everything for you. But very important, monitoring of driving environment is done by human driver, must be done by human driver. You are the one who must observe everything. And more important, the fallback performance, it is done by the human driver. If something goes wrong, it is the job and responsibility of the human driver to take control. And as I said, we have the traffic jam assistant, parking assistant, but the most important one, Tesla autopilot. So why Tesla autopilot is level 2? Because the human must observe the environment. Of course, you have lots of sensors in Tesla, but who is responsible is human driver. And if the system doesn't react, who is responsible is human driver. And now comes the question. Lots of accidents happen with Tesla. Or I don't say lots of accidents, this is a little bit exaggeration, but when an accident happens, it's almost never the fault of Tesla. It's always the fault of human driver, because the human driver must be always, or he is or she is always responsible of driving the vehicle. So now I show you some videos. This is our first video. there is a Tesla, there is a truck on the road that had an accident, and the Tesla does nothing, simply drives towards it with the maximum velocity and crash. So what it means that here the driver simply activated the autopilot. He's reading a newspaper or he's doing something else, and nothing happened. And you can see that here the system that has, of course, lots of camera simply didn't detect this vehicle. So there is, of course, a problem in the perception. The object is not detected, is not classified, or is detected as maybe a shadow of the bridge or whatsoever. And as you can see that the Tesla does nothing. And you can see that in the text that the Tesla reacts really in the last second. So it was too late. But why it is not the fault of Tesla? Because we are talking about the level 2 automation. It means that it was the responsibility and the job of the human driver to observe the situation and say, okay, there is something, Tesla cannot do this. Then I overtake, I take the control back from the system, and now I am the one who drives the system. I'm the one who controls the vehicle, and I could simply avoid it. There is another example. Unfortunately, this one resulted in a death. This is an Uber that is using a Volvo car, and as you can see, it simply doesn't see this pedestrian that has also a bicycle, so it's a big object. And you can see here the driver that is seated there, and her job is simply to observe the environment, is checking her mobile phone or reading a newspaper. I don't know, I cannot see it. And the moment that she realized it is too late, and we had the crash, and unfortunately this pedestrian was dead. So this is a fatal accident. So you can see that when we talk about level 2, the people, they really must understand what is the meaning of level 2. It means that if you buy a Tesla tomorrow, it means that you must pay attention because it is your responsibility. Okay. Then we move to the level 3. And as I said before, level 3, it is a level that it doesn't exist right now on the market. This is the level that we have in the research and development. What it means that, okay, execution of the control command on the steering angle and acceleration, deceleration is still by system like level 2. Also monitoring of driving environment is by system, but the fallback is always by human driver. If something goes wrong, human driver. We have some example of the platooning. There are lots of research projects that you had the big truck that drove in the USA. Then they form some platoon, they drive behind each other, and that was some sort of level 3. There is always driver on board, but the system monitors everything. The system also controls the vehicle. Only when something goes wrong, the driver must react. And this is research and development. We have level 4. And in level 4, we have also the fallback. The fallback goes to the system. So it means that this is a high level of automation. And this is an example of the Google car. You have a Google car, which is level 4. Of course, here, based on the system definition, you do not need to have a driver on board. But the problem is that this system does everything, but only some driving modes. It means that, for example, if you are on a highway or if you are in a city, then it can drive for you and it can be responsible of anything. But if your car is parked in your garage and then you said that I want to go to university, it doesn't do everything. Of course, maybe there are some parts that you need to do by yourself. You know, if there is a U-turn, if there is a backward, or if there is a parking maneuver, maybe you need to do by yourself, but the rest, it will do it by itself. And it's also monitor, is responsible of the fallback, and is also responsible of the control. There are some series example, but of course not in the city. On the construction site, when you have the separated lanes, there are the people mover that they do everything with the level 4 of automation. There are the automated transport of goods on the factory premises that they do it. And in the research and development, the most famous one is a Google car. We did lots of valet parking scenario, and there are some videos on YouTube from German Aerospace. You can see that you get off your car, you use your smartphone. You said, okay, go and park my car because I want to go to a shopping center. The car does everything alone, find the parking lot, park the car. When you are back, you use again your smartphone, the car drives back. You can do it in a shopping center, in airport. This is a typical valet parking that someone does it for you, but this is an automated one. And as I said, this is mostly in research and development stage. And the most famous one is a Google car. So when you watch a video of Google car, you know that, okay, we are talking about level 4. And level 5 is a system very similar to level 4, just that here we can handle all driving modes. It means that you have a vehicle that you just said that, okay, I want to drive there. You give your destination and the system does everything for you. And it performs all the driving modes. So if it's the driving backward, forward, park the car, anything, U-turn, it does everything. You don't need to do anything. It means that the system can also drive without driver. It means that you say, okay, come and pick me up. So the system will drive without even driver, or you don't even need even to have a driver seat. In the next generation car concept, you see that there is no driver seat. You can sit directly behind or driver sit in the opposite direction because you want to have a chat with the other passenger. So the cars does everything independent from all the obstacles. And of course, the degree of the maturity is that is the research. And right now, we don't have any system. I mean, in the research area, of course, you can have, but on the market, or okay, someone did a car that can does everything. This still doesn't exist. Okay. And when we talk, of course, about the autonomous vehicle and autonomous vehicle that can does everything, it means that the car must drive inside the city, inside the countryside, it must drive in the highway and everywhere. Okay, so that was the part that we talk about the autonomous vehicle and this 5 or 6 different level of automation. But for us, if we are interested in this field and we want to work, we need to know the architecture of an autonomous vehicle. This is very, very important to know that what are the different modules that they are involved and are there to control the vehicle or to do all this driving tasks. And maybe later on you end up in one of this sector and working there. So the important one, or the most important one, is that we have the perception stack. So is all the sensors that you have in your car. If you have some LiDAR, if you have some radar, if you have some cameras, they create a perception module for you. Then we have a fusion. It means that you receive the information from different sensors and you need to fuse it. So that, okay, I think that my camera said that this is an obstacle. Then I use my LiDAR sensor to say, that, okay, this is so far from me, so I can fuse this information and say that, okay, I can classify also the information so that, okay, there is an obstacle there on the road with 90% probability. Then we have a navigation and localization, just to say that, okay, I am in the A, I want to go to B, which route I must take. And of course, you need the localization if you use some other localization technique with your sensors, or if you have a GPS on board, just to say that where I am located right now in the world. Then we have world and environment modeling stack, just to create a model of the world. Then we have the prediction to predict the behavior of the other road user. We have route behavior and motion planning, when you plan a motion, and so that in order to move from A to B, you need to follow this trajectory. And then we have the control just to guarantee that this trajectory is followed. I have 39 messages in chat. I don't know if I need to react to them right now, but I would kindly do it at the end. Okay, so we can continue now the discussion. So let me try to take a look to the architecture of the autonomous vehicle. Usually we see something very similar to this. At the beginning, you have the sensors. You can have a different sensor. You can have your camera, radar, LiDAR, GPS, and the other sensor that you have, and they create the perception module. And what it means is that they have their job is to detect. So it means that, or they detect where is the lane, or they detect what is the traffic light, which phase it has. They detect the traffic sign. They detect the object, and they try also to track them. So, okay, there is a car, and this car, based on the previous trajectory or the history of the trajectory that it has, is staying on its lane, or it wants to change the lane. So some object detection and tracking happens. Is very, very important. There is a free space detection when we talk about the valet parking, or if you want to park your vehicle. Then we are talking also about the free space detection. There are lots of module that we can have, or we can add to the detection and to the perception. Then, of course, we have also the localization, because it is very, very also important to know that where we are located in the world. Then we have the planning. This is the module that I am working in the last 10 years. This is mostly about the route planning, having the prediction, behavior planning. So, okay, do I need to stay in my lane, or is it better if I change my lane? And if I want to do this, what will be the trajectory? Then I need a trajectory. And the trajectory means that you need to consider the vehicle dynamic, and so that if you want to follow this trajectory, so this is the amount of a steering wheel that you need to apply, and this is the amount of the gas pedal and the braking, or maybe more in the scientific terms, this is the amount of the torque that you need to apply to your car. And then, as I told you in the last part, we have the control just to guarantee that the vehicle stay on this trajectory. So we can have some conventional controller. So if you're familiar with the control engineering, you can have the PID controller. You can have some other techniques, some modern techniques, some predictive techniques, like an MPC techniques, like a model predictive control, or you can have an optimal control approach, H infinity, anything that guarantee that your vehicle stay on this trajectory. Okay, so now if I want to put it and say that, okay, what are the modules that they are involved? You see that an autonomous car has a different module. Of course, this is simply an abstraction. You can go into the more details, but what we have mostly is that you have the actuator. So you have a motor that moves your car. You have a steering system, steer by wire or any other type. So you have your actuator. You have your automation function that is mostly the part that you plan a trajectory and you control your car. You have your perception, you have your sensor, you need a map. So you see that there are lots of modules that they are involved for this autonomous vehicle. And then you have the communication to the outside. You can have the communication to the other road user. You can have the communication with the infrastructure. You can have the traffic management and control center. And you can have some HMI. We have some internal HMI that simply the driver can interact with the system. So this is a human machine interface. And you can have some external one. For example, the example that I gave you, that you use your car with your smartphone, say, okay, go and park or return back and pick me up. These are some external HMI. Now we can take a look with more detail to each of them. When we talk about the sensor, this is a very, very interesting field of research, and there are lots of challenges there that researcher they can get involved and try to solve it. Is that Tesla going in the direction of using only camera, but in most of autonomous vehicle, maybe when I say autonomous vehicle, I don't explicitly talk about level 5, but other levels like level 2 or level 3 that we are developing in the German aerospace, our car is equipped with lots of sensors. So we have usually stereo cameras in front or in the rear. Then we have a different radar, mostly the ACC radar in front, just to give us very, very long vision range. Then we have a different LiDAR. The LiDAR are all located around the vehicle. For example, you can have a tree in front or tree behind on the bumper to give you almost 360 degree of a vision range. You can have all these LiDAR point, and then you can classify them and detect some object in the combination with the other sensors that you have. Or you can have something like a Velodyne that you have it on the roof. Here is a rotating LiDAR that is, you saw it probably in the example of the Google car that is rotating and gives you an image of the environment in the real time, and this is 360 degree. So you can have a different type of sensor simply to sense the environment. The other important thing is a digital map, because most of the car that we are designing, they are the car that we design for the structured environments. Of course, you can have also a car that deals with the unstructured environment. If you are in a parking area of a shop, or I don't know, if you're off the road and there is really not a structured environment. But when we talk about a structured environment, it means that you have your road, you have all the connection between the road, the intersection are defined, the direction of the movement are defined. So you know that if you are located, for example, in this special lane, this lane has an ID, you know where you are located, you know from this lane where you can go, in which direction you can go. You can combine it with your navigation and find the route and then drive. So the digital map is very important. It gives you the information about the road boundaries, it gives you information about the center of the lane. So it's very crucial when you try to plan a trajectory and you want to keep the center of the lane. And what is important also is that later on you can add the object that you detect with your sensor on it, because maybe you detect thousands of the objects, but none of them are relevant for you. Then you can add some filtering and say, okay, filter out all of the objects that they are out of the lanes, because if you drive in a city, you have lots of people that are walking, and you said, okay, give me only the objects that are relevant for me, they are located on my lane, or if I want to change my lane, give me the object that they are located on the other lane because I want to plan a lane change maneuver. So digital map are also very important. There are lots of companies like the TomTom, maybe a famous one, that are doing lots of development in this field, and to create this map, to have it always the updated version, the latest version, add also some information on it that helps for localization, add some special point. I think that the name of the things that they did is a road DNA, that you have some special places on the map, like a special building or something in the city, that if your sensor detects that, you can use that information also for localization. So, okay, now I know that I am located in this place. So the digital map is also very, very important field and module that already exists. Then we have the infrastructure that can send the information to the car. Infrastructure will play a crucial role when we talk about the transportation from macroscopic point of view, when we try to manage the congestion and the traffic of a city. So this is a picture from the city that I work, and this is a logo of German Aerospace. The city is almost each intersection, the German Aerospace has a camera and the sensor and can observe and track the traffic and can send the information. I mean, this is something that already you have it on your smartphone. You said, okay, I want to move from A to B. Your smartphone will tell you if there is a traffic on the road or not. So we have it, but you can have it directly also inside your autonomous car module, that you have an infrastructure, and via communication, it sends the information, and then you get the information. You can plan the best route for yourself with the less traffic, or you can get even more advanced information, such as there is an accident on the road, there is a construction site, and so on. So the infrastructure is also very important. That, of course, is linked directly to the communication module, because we get the information via communication.